So, like, we need to get through, this is hurricanes, okay? So we need to do hurricanes and weather forecasting in a week. So we have Wednesday, Friday, Monday, Wednesday. So we have 4 lecture days. So it should do okay. And we'll see how much time we have to look at some videos. I love the videos, so I don't know. Your textbook has some cool pictures, though. So we'll kind of see. So hurricanes, anybody in here been through a hurricane? No?
Almost.
Almost? Do tell.
I left right before.
Which one was it?
I don't remember. It was years ago. I was down in Florida visiting my aunt. We left, and about a month later it hit. That would be interesting to see it on the news, like where you were. Yep. So, yeah, they can definitely leave their mark. So there's all sorts of things that you already know about hurricanes. One of the things you may know is that actually before they become a hurricane, have you ever heard them talk about tropical storms? Okay. And these actually are a pair of tropical storms. So meet from left to right, Boris and Christina. So you guys know that they're alphabetical now? They're named them?
It's in 1 year, isn't it? And then the next?
They alternate. Now they used to have all women name, and now in the same year they alternate male, female, male, female, male, female. So we'll talk about naming them. So tropical storm is just these actually never became hurricanes. Okay, they never got that far. They never got upgraded like that. But when they're tropical storms, they get named, whether they become a hurricane or not. So that's kind of cool. So hurricane, one of the things I'm hoping that you get and remember for the future is that that's actually our name. The generic name for a hurricane is a tropical cyclone. And, of course, cyclones in the northern hemisphere and southern hemisphere are low pressure. So at the center of a hurricane is going to be a low pressure, at the surface anyway. So in order for something to be a hurricane, it's got to go, the winds have to be at least 74 miles per hour.
Is that sustained?
Mm-hmm. I think so. So I'll go ahead and put up these 3 names, okay? So these are all tropical cyclones. So a hurricane is a tropical cyclone, okay? A typhoon is a tropical cyclone that is in the western Pacific, and I'll kind of show you where that is. And a cyclone is a tropical cyclone that is in the Indian Ocean near Australia. Okay, so those all 3 mean tropical cyclone. And we're going to talk about, and the next figure actually shows you a map of the world and kind of shows you these hurricane, typhoon, cyclone, where they call them the different names. And look for them to kind of begin off the western edge of an ocean basin. See if you can kind of see that. So hurricanes are here. And notice how we have a hurricane in our Atlantic Ocean basin. And actually we have a set of hurricanes that can form off of in the Pacific Ocean too. They have 2 different sets of names. I just think that is so cool. And these all have different sets of names. Of course, if you're in that part of the world, is that like Japan? Mm-hmm. Okay, good. So if you're in that part of the world, you're going to call your hurricanes different names. So they have a different set of names. But they call them typhoons. Sorry, they don't call them hurricanes. They call them typhoons. Like a super typhoon or whatever. That's a tropical cyclone. Their typhoons are our hurricanes. And then these folks call them cyclones. Okay, so near Australia, they don't call them hurricanes, they call them cyclones. So if they talk about a cyclone there, that's not a tornado. That is what we would call a hurricane. So kind of see if you see where they kind of come from. They come from the, looks to me like they come from the eastern part of the ocean basin. What do my things say?
Western.
Yeah, I think that needs to be changed. Okay, so they basically come from the eastern part, and actually they're going to take those easterly trades over. So hurricanes, that's just for us, right? For tropical cyclones. Our tropical cyclones, the worst one as far as deaths are concerned, occurred back in 1900, Galveston, Texas.
And I think, see, Galveston was number 1 and Galveston is number 9. You're like, dude, really? So when you think of Texas, of course, you think of the Gulf of Mexico and that sort of thing. And they have that warm, moist air that can actually kind of fuel the system that's been coming along the Atlantic Ocean, clear from off of the west coast of Africa, actually. Of course, you see Katrina up there with 1,833 fatalities. It sounds like kind of a rounded number. I mean, I think the number should be more rounded than that. I think actually might be even more than that.
That's crazy too, because there are like none that are super deadly from 57 all the way to 2005. It's a long time to go without
That
one of
is.
the top,
Yeah,
9.
what's Autumn's saying is, you had Audrey in 1957 and Katrina in 2005, but you don't see a lot between there. These are fatalities. Now, the thing about fatalities have decreased because weather forecasting has become better. So that's one thing about it. Another thing I think is interesting, like with the slide, is do you see where they started using the names? So, and I think it is in the 50s. But before the names, they just had to kind of say where they occurred. Like that, for instance, that these are old ones, okay, because they don't have the girls' names or the names at all. So anyway. So this is just some historic hurricanes. Now, if a hurricane becomes infamous, like Katrina, okay, the name Katrina will never be used for another hurricane. If it's just a regular hurricane, actually we're going to see that they recycle the hurricane names. Okay. So, I don't know if you see any of these ring a bell for...
The Katrina one.
It was Katrina, goodness. Well, we're glad that you left. The thing about Katrina, if you look at the documentaries on it, it was kind of after the fact when the levees started failing that they really got, all that water came in and filled New Orleans like a...
All the trees and the swamps were all bent completely over. It was bad.
It was not good. So the convention used here is, you see the dots versus the solid line? The dots are like the tropical storms. Yep, they aren't the full-fledged hurricane. So, and then if you pick on, let's see, that red one, Galveston, yeah, that's a good example. You can see, like, for instance, right here, okay, it's just a storm. I'll put T storm for tropical storm because of the dots. The other thing is if we pick on Galveston, look at this. Okay, actually it is a tropical storm here on land too. Galveston, the first time they got creamed, right? Now we've got different building codes and stuff like that. It's definitely helped. But can you imagine? This is the aftermath of Hurricane Ike in 2008. Looks like the Atlantic Ocean is not too far from there. Well, this is Texas, so that would be probably the Gulf. Yeah. One of the things that there's many destructive forces associated with a hurricane, but one of them is called storm surge. And basically it's a wall of water that's swept onto shore as the eye gets to landfall.
I think that would be scarier than anything. Seeing that water.
Yeah, I do too. It'd be like a typhoon, kind of like a...
What's those, like a... I just can't imagine seeing a big wall of water coming at you.
So hurricane, tropical cyclone, same thing, right? And so we're going to see some pictures of these features, kind of the anatomy of a hurricane. It has the spiral rain bands, right? So if I was drawing this, you probably call these are the, you've seen kind of the, when we saw Christina and Boris a little bit ago, kind of the spiral rain bands, those are heavy rain. And then we have the eye, okay? That's the center of it. And since they're called cyclones, like I said, you think low, and there's a low pressure at the ground there. And then we have the eye wall, which actually, if that's the eye,
then the eye wall, I'm going to put little circles here. And you know, in the previous chapter, we talked about good old-fashioned thunderstorms. So kind of think of that, those little circles as being thunderstorm cells. So that's kind of how I picture that. Yep. So a figure from your textbook that kind of shows you can see the spiral rain bands, okay? You can see the eye. Can't really see the eye wall very good. But I'm going to go ahead here at the surface, put an L for low, okay? That's my low there. So one of the things we know about lows is that basically air is converging there. And how do I say this? The lower the low for in the eye, the nastier the hurricane. So that's one of the ways, you know, we're going to talk about Cat 1, Cat 2, Cat 3, Cat 5, Category 5 hurricane. They look at how low that low is. So we have converging air, and actually, I think kind of created to the, maybe not created by that, but I'm going to go ahead and put an upper level H here, okay? So here at upper elevation, over the eye, we have a high, we have a low here. Yeah, and Autumn's up here doing her finger like this. So basically, if you look at the low, you're going to look at basically it going counterclockwise around the low, okay? So like this around the low and clockwise around a high, like this around the high. And we talked about, and I hadn't thought much or chased this down, but we've kind of talked about how wind shear is basically changing wind speed or direction with elevation. We definitely have at some point air going like this and air going like this. So, you know. But if you watch the movie The Day After Tomorrow, yeah, it's where it's true that inside the eye it's nice and calm. So, yeah. And you can tell that by this over here. Actually, the red here is the wind speed. So basically they're saying as the eye approached, the wind got faster and faster and faster. In the eye, it goes down to 0, just like the movie. Like, okay.
So, it seems weird to me that you have air, you know, going counterclockwise, of course, up around the eye, but then there's actually like warm air being pulled down into the eye. Is that type?
Yeah, and that warm air, like it says, the subsiding air, that's from the high up here.
Okay.
You have a low down there. And so one of the things we know about subsiding means to go down. So if a chunk of air is forced down, it's going to get smaller and smaller and smaller. It's going to be warm, yeah. Adiabatic warming. So that kind of, from that high, that clockwise motion of air is actually called an outflow, the outflow. And not to be confused with when we talked about in the previous chapter, we talked about something called inflow. I think that's funny, they both caught the word flow. So inflow is associated with the updraft of a thunderstorm, and outflow here is associated with that air going out upper elevations. So this is, I think, I'm not sure if this figure is your textbook or not, but it kind of shows what we were just talking about. At the bottom, I'm going to put an L. At the top, I'm going to put an H. So here's my, what color can I pick? I guess green again. Here's my L, a low pressure down there, and here's my H, a high pressure up there. Okay, so that's kind of what you have going around the eye. Yeah, I don't think it was there either. So some folks would say, since the eye is nice and calm, why can't we just stay with the eye and go where the eye goes? It's a thought, okay? Basically, the eye is about, average diameter, it says here is 20 miles, okay? And it's going at a speed of about 12 miles per hour. So if you knew where it was going, you know. But you figure basically by the time the eye gets to you, probably you have undergone the destruction of the spiral rain bands, and not to mention the eye wall, so you're pretty well shook up. Okay? And then, though, after the eye passes you, guess what you get? The other part of the eye wall and the other part of the spiral rain bands. So I don't know what the strategy there would be. Leave. Strategy.
So from left to right here, we have a couple of surface maps, and this is Hurricane Fran. Notice it's classified as a hurricane on the left, but a tropical storm there on the right after time occurred. The other thing, can you see on the right where Fran actually has moved onto land there? Yeah, and that's one of the things. If they move onto land, then they don't have their water, and that's part of the things that fuels them. So
And the pressure gets
typical.
higher than once it moves on to land pressure rating.
Right, yeah, you can see the bullseye is less tight. Definitely when it's a hurricane, that's crazy. Those isobars being that tight, you have a lot of wind there. Not good. So if you're looking for ingredients to make your hurricane or your tropical cyclone, these are what you need. So you need warm water, as defined by 81 Fahrenheit or greater. That's why, with global warming, with temperatures warming, our surface temperatures and the temperatures of our oceans getting warmer, you would think that this ingredient has increased, but that's not the only ingredient to get tropical cyclones or hurricanes. The other is that you need to have enough twist, the Coriolis forces twist, okay? And remember, one of the things we talked about is that if you get near the equator, the Coriolis force is nothing, yeah. The Coriolis force is strongest near the poles. And so you have to be at least 5 degrees away from the equator in order to get the twistiness that you need for your hurricanes. And then the other one is you need to have basically unstable air. And we've talked about stable atmosphere and unstable atmosphere. So it needs to be convective lifting. Okay, it just, some sort of lifting mechanism, probably convection. All right, so on your test somehow I'm going to kind of try to ask of you, what are the stages of a hurricane? Or what are the stages of a tropical cyclone? It's the same thing, with stages of a tropical cyclone. And this might be the first stage, okay? We talked about easterly trade winds with the Hadley cell. That's actually what these are, easterly waves. Here in the Atlantic Ocean basin, where we get hit kind of on our west coast, maybe even the Gulf, the storms start out off of in the eastern part of the ocean basin, right? And they take the easterly trade winds over. So kind of those little puppy things you see here on the diagram, those actually are little cumulus or thunderstorm clouds, cumulus clouds. Okay, so that is showing, that actually I think it says tropical disturbance. Okay. So, speaking of tropical disturbance, some would say that the easterly waves isn't really a stage, but I think it kind of is. But kind of embedded in those easterly waves, I guess more properly, is the beginnings, potentially, of a hurricane. So the real first stage, I guess you would call tropical disturbance. Okay, tropical disturbance. A little kind of a cluster of thunderstorms. So it can continue to mature depending upon its access to warm water, instability, rotation. And the next stage after the tropical disturbance, and I would put this on my note card because I always get disturbance and depression mixed up. So it starts with a disturbance and then it goes up a notch to depression, tropical depression. And they kind of keep an eye on the wind speed to know when it's gone to the next stage. So then, if it goes ahead and it matures and the winds get faster than, winds get about 39 to 74 miles per hour, okay, then you're talking about the Boris and Christina we saw a minute ago. Okay, that is a tropical storm. So it gets its name. That's so exciting. We'll talk about names here in a minute, like I said. So then if it continues to strengthen, it can become a hurricane. So remember, tropical cyclone and hurricane are the same thing. So those are the, I guess, 4 stages. Tropical depression, tropical disturbance, I did it wrong. Tropical disturbance, then tropical depression, and then tropical storm, and tropical cyclone. And they can be downgraded, okay, like we saw, it goes over land. It goes then from a tropical cyclone or hurricane to a tropical storm.
And that's it. Pretty cool. This is kind of a silly slide, I think, because the orange line is tropical storms and tropical cyclones, okay, or actually hurricanes. Tropical storms and hurricanes. And then the red line is just hurricanes. So I'm kind of trying to show you that
How many
they're,
tropical storms turn in?
yeah, kind of relatively speaking. But you can kind of see that actually this is just for our ocean basins, okay, and the peak of the season is looking like September-ish right there, so. Because you figure it takes a while, there's a lag when those oceans get nice and warm and toasty, yeah.
There's a lag from probably August to mid-September, when the oceans are still getting warmer.
Yep. Okay, oh, so here's the one naming things. Naming not only things, but tropical storms. Remember, tropical storms is when they get their name, okay? So each ocean basin has its own set of names. And we're going to look at those sets here in a minute. In fact, if we pick on North America, there's a set of names for our Eastern Atlantic. That should be Western Atlantic and Eastern Pacific, shouldn't it? I don't think so, because if you look at the Atlantic Ocean basin, that's the. Does that seem right?
I mean, if you look at this figures that they have, I mean, this kind of is the eastern part of the Atlantic
I
basin.
suppose.
moving
Okay.
in.
Okay, I'll buy that. So it alternates male and female. So you may be wondering, what about, they're alphabetical, that's fine, but is it hard to find a name that begins with Q? And the answer is yes. So we skipped that name. So Q, U, X, Y, and Z are not there. So that means, let's see, 1, 2, 3, 4, 5. So you have 21 letters of the alphabet. So if you have more than 21 tropical storms, they don't have to be full-fledged hurricanes. They get named at the storm level. If you have more than 21 tropical storms, which we did the year of Katrina, then you have to go to the Greek alphabet. Start naming them. The list of names is recycled every 6 years, so I'm going to show you a figure in the textbook, and it's going to show you, like, for 2015, what our names should be. Okay, and it's going to show you for 2016 what the names would be. And then, as long as there's no infamous hurricane, those lists will be recycled. So like I said, if it's an infamous hurricane, the name will be retired. So a figure from your textbook. So this is 2015, and I usually look and see if there's anybody's names in here, but I don't think so. Okay, so you can see it's alphabetical. Yeah. So in 2016, this is what they'll look like. So I said 6 lists. So in order to get the list for 2017, actually, we need to wrap around. Okay. So in other words, see where it says 2011? That's actually the list for 2017. Yep.
So if there was, say, in 12, there was a super bad one, they wouldn't recycle just that name, the rest of the list they would, but replace that particular letter?
Right. Yep, they would pull that name from the list. Anybody see your name up there?
I never see my name.
Oh, it looks like they're really smart because they go, like if you pick on the E's, it goes female, male, female, male, female, male. That makes sense. They're so smart. Do you guys remember when they used to, or was it 2 years ago when the Weather Channel was going to try to name winter storms?
Mm-hmm.
So I think that was harder to do. I don't think it caught on.
What was the one that they named? Did it hit the...
Oh, Sandy? But that was a tropical storm, actually.
So weird.
Yeah, it is weird. So here are the other lists. Maybe. Oh.
No wonder. So WMO is World Meteorological Organization. And actually, when we talk about weather forecasting in the last chapter in this unit, we'll mention the WMO. But there's all sorts of places out there to get these. So the Caribbean Sea, North Atlantic names. This actually is the list we just looked at. You guys see the top one? So here, though, this is another list of names. I can recognize those as names, right? So that would be for the Pacific Ocean.
They use X, Y, and Z in those.
Yeah, they do. I noticed that before, or the other day. They do use X, Y, and Z. Then we get into some names which I probably don't recognize, but if your if your native language is Chinese, list of names. And they don't really do the whole alphabetic thing. That's what I think, just by my looking at it. Australia, they get to come up with a list of names. Definitely don't recognize those. Notice how they do theirs. They do W, X, Y, and Z kind of clustered. So you kind of get the idea. Oh. Cool. So, in this unit, in Unit 4, we talked about tornadoes, okay? And now we're talking about hurricanes, and there are two different scales to rate them. The tornado was the Fujita, or enhanced Fujita scale. And tornadoes are ranked after the fact. And you can have an EF0 through EF5. And this is the Saffir-Simpson scale, okay? And for hurricanes. And you can have a Category 1 through Category 5, Category 5 being the most intense. And they categorize them as they're occurring because they can change their category, right? So the things they use to categorize them are the current wind speed, but they can also use the pressure, that low pressure that we talked about. The lower the low, the nastier the hurricane. And they can also use something called storm surge to categorize them. So this statistic always kind of surprises me. Maybe it's because after we talked about tornadoes, we know that there are EF5 tornadoes, and they're rare. But as far as Category 5 hurricanes affecting North America, there have only been 3 Cat 5 hurricanes. Really? And 16 Category 4 hurricanes between the years 1900 to 2005. So Category 5 is...
Katrina was 4.
Katrina, I think, was a 3 or 4. I don't know if it said.
4.
It was a 4. Mm-hmm. So here on the left is the Category 1 through 5. The next column is how low that central pressure is. The third column is how fast is that wind blowing. The next column is how high does that storm surge push that wall of water. Okay, and then the last one is what can you expect with regard to damages. Category 4, like Katrina, extreme damage. Category 5, catastrophic damage. And I haven't mentioned this, but this is the obvious, right? When you look at where people are living in the United States, the coastal regions are highly populated. It's the cool place to live. But I think early on it was settled because of transportation reasons. But it's just So this colorful figure actually is showing you an assortment of things, starting with, let's see, what's before tropical depression? Tropical disturbance, yeah. Doesn't show the disturbances, but shows the depressions, the tropical storms, and then the hurricanes in their different categorizations. So as far as monitoring the hurricanes, we can use, or they can use something called drop wind sounds. Drop wind sounds, that's a weird name. It's like the reverse of sending up a weather balloon. So instead of sending up our cool weather balloons with a little gizmo box, it goes up, okay. Instead of doing that, basically you go in a plane and you drop something down. Is that not cool or what? I had a student look up how much they cost, and they cost about $300 to $400. So, and they are recoverable. So anyway, that's kind of.
They actually fly over the hurricane, drop it.
They fly in the hurricane, and it's kind of the spiral rain bands and everything. Yeah.
Seems.
Maybe over. It does seem dangerous.
You have an idea of the wind speed when you're up there trying to drop them.
Yeah. And someone was saying, and this makes sense too, of course, our military, with their knowledge in the Air Force, are the folks that work with weather people, I think. So there is basically the parachute thing. That is your drop wind sound dropping through. And it's got global positioning, GPS. So basically, they can get information about wind speed, being carried around, and sends back information about pressure, temperature. So there you go. And maybe they do fly above the hurricane. I don't know. It seems safer. So hurricane movement. Actually, it's the upper level. It's the jet stream, kind of the Rossby waves that may or may not kind of get the thing to steer, to move from point A to point B. This idea of tropical storms wanting to become a tropical cyclone or a hurricane, seeking warmer waters. I don't know if it necessarily seeks warmer waters, but it almost seems like they have a personality of their own. I know they don't. But hurricanes tend to, and I'm going to use the word recurve, they tend to kind of go around, actually what we're going to bring into what we talked about before, the semi-permanent highs there. And when they go towards the poles, whether it's north in our hemisphere or south in the southern hemisphere, when they go toward the poles, they go over cooler water, and it's just like going over land. They kind of start to peter out. So when we talked in the last unit about the Hadley cell and the Ferrel cell and the polar cell, we said that actually between the Hadley and the Ferrel cells, there was descending air that kind of creates a band of high pressure. And then over the ocean, and we talked about the Bermuda Triangle, the Bermuda High there in the Atlantic. And actually around a high pressure, then we're talking about clockwise in the northern hemisphere. And actually that's what makes our the movement of our tropical cyclones or our hurricanes when they get to our Atlantic hurricanes. So we're going to look at some more pictures of kind of paths that hurricanes have taken, and we're going to kind of look for that, what they call recurving, basically kind of skirting around the United States East Coast, okay, around that Bermuda Triangle, Bermuda High. So here, meet Charlie, Hurricane Francis, Hurricane Ivan, and Hurricane Jean in those three different colors. And so the thing about the recurving is I could put the letter H out here. Okay, that means my high pressure, Bermuda High. And again, in the northern hemisphere, we're looking for clockwise motion. And so actually that's kind of what causes that to happen. One of the things they kind of highlighted, check out Florida getting hit by these three different hurricanes. But look at the paths that they take over the, is that the Panhandle? Is that what they call it? Okay. Cool.
You could, 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 you Hurricane Gene. Just after it becomes a hurricane, it like does a loop-de-loop and then.
It does do a weird thingy right here. This one right here.
Yeah.
You're
It's still
like,
like a
really?
tropical storm, and then as it's becoming a hurricane, it like loops around.
It looks like it's recurving, and then it kind of comes back and up around. Yeah, it's the dots. Yep, are tropical storms, and the solid lines are hurricanes. So, yeah, and look at the green one. Look at Ivan.
Oh, yeah.
It's like it goes over land, comes back out. You're like, really?
Can't get rid of me. I'm coming all the way around.
Yeah.
Here's all the way around Florida over to Texas and Louisiana.
One of the last slides in this part is we talk about forecasters, meteorologists who try to anticipate where they're going to go. And I love the phrase, have you ever seen the cone of uncertainty? So like if like where my palms are meeting, that's the current condition. Then they kind of say, well, it could go, this is like where it could go, okay? So basically, it could be up here. That's the cone of uncertainty. So can you imagine, it's like, I don't know. But upper level winds are steering those. Either that or aliens. Sorry, I'm curious about the whole alien thing now. But that's a whole other subject. Oops. Okay, so another set of hurricanes. You can kind of see the recurving that's going on. Different set. Oh, actually, this looks like the same slide we looked at before, historic hurricanes. It is. The blue one? Yeah, opal. You're like, really? That is crazy.
Jumped over.
I agree. That is weird. And you guys, Hurricane Sandy, right? Or Tropical Storm Sandy? I'm not sure. But the thing about that is that it kind of looks like Floyd, maybe, doesn't it? If you look at Floyd, that's actually kind of what Sandy did.
Wasn't it winter though?
Yeah.
So
It was
isn't that
like
pretty odd?
November, was it?
Yeah,
Sandy.
it was early winter, I think. But I was just thinking, by then you'd think the water
oceans
would
would be.
have started to cool quite a
Yeah,
bit.
and actually, you're raising a good point. Hurricane Sandy, there was a bunch of talk about global warming, and you need your oceans to be nice and warm in order to support that sort of activity. The other thing about Hurricane Sandy, Tropical Storm Sandy, is that hurricane was that they talked about storm surge, and the problem was it was like a full moon, I want to say, or a new moon. Both full moon and new moon basically have what's called a spring tide, an extra crazy tide, and so that did not help matters at all. No. So, what's going to get you? There's 3 options with a hurricane. Actually, there's another option coming up, but the winds. Remember, with Hurricane Fran, they showed the really tight isobars. Okay, strong winds associated with the weather system called a hurricane. Heavy rains, and I usually think of the heavy rains and the spiral rain bands. Like, dude, if it's a big old system and the whole system's going to cross you, you're going to get drenched, right? The tornadoes that can be, we talked about tornadoes in the previous chapter. Anytime you get a thunderstorm cell, you can get a tornado that drops out of it. And so the eye wall is basically a bunch of thunderstorm cells, and basically also embedded in the spiral rain bands are also thunderstorm cells. So you can have tornadoes there.
You're in the middle of a hurricane and having a tornado drop
Like,
on you.
dude.
Come on.
It's like insult on top of injury. So I guess a fourth thing that could get you is this storm surge at landfall. Kind of an initial sort of, here's the eye of the hurricane, and here is all of that crazy water associated with the crazy wind associated with the crazy eye. Okay, so remember, the storm surge height is a way to categorize the hurricane. So the place that's going to get the worst storm surge, and I tried to kind of depict this before, if you're in a swimming pool and you put out your arms and, the water's up to your arms, and you're going to go around, okay, basically
the motion that you're going, and I'll go ahead and go counterclockwise because that's what the low is doing at the surface. That motion is going to bring that wave of water, wherever you go, okay? And let's just say I'm headed that way. That's going to be my land. The place that's going to get my most wall of water is actually going to be over here on my right side. So that's why storm surge actually is worst over here on the right. So Katrina, right? Just some pictures, and check out that is there on the right. That's a railroad tracks with houses located, or a house located on a railroad track. If you're like me, you heard a lot of sad stories. One of the sad stories was, if I understood it right, when folks went to go have insurance companies work with them to get back on their feet, the insurance company would say, well, I don't know, you're not covered for flood here. If it was like a storm surge, okay, that's the flooding that got you, and that's not what your policy's for. You're like, dude. So there were some of those kind of technicalities that went on. Like, really?
Technically, it is storm damage, though, even if it is water damage.
Yeah, I know there was definitely going back and forth between the people who applied for help and. But I think one major insurance company said we're not dealing with hurricane-prone areas anymore. They basically pulled all their policies. Like, well, that's real mature. Yeah. So again, kind of talking a little bit about storm surge. How many pages do we have? Oh, yeah. Well, there's not much left, but let's leave those last few slides till next time, and that'll kind of spread out the fun. And so, since we got through all this blah blah blah, I think we'll have time for some videos on Friday. So bring popcorn. Okay, any questions?
Is there anything due Friday?
Nothing due Friday, but it will be due Monday.
So did you say, are we having a